Hello guys. In today's lecture we're going to be solving the following homogeneous differential equations. Why don't you grab your pen and solve along with me, and I believe you are going to learn a lot in the process. So we're going to begin with problem 1. So this is an IVP, okay? And the reason is we have a differential equation given to us with an initial condition. So an differential equation plus an initial condition is what we call an IVP. Now if you look at this differential equation, 2y minus x y prime is equal to 2x plus y. There is no way that you can separate the variables. In this case, there is no way that you can separate the variables. So everything about this equation is just homogeneous. Okay, so y prime is 2x plus y over what? 2y minus x. So this is our differential equation. And do you remember the test, the homogeneity test? Let me just refresh your mind on the two tests that you can carry out to test for homogeneity. For instance, you need an f of x comma y, okay, such that if there is a lambda, which is a non-zero constant, f of lambda x and lambda y should be lambda n f of x comma y. So assuming you want to take the numerator of this particular right hand side, which in this case is equal to 2x plus y, you can call the denominator 2y minus x, and you want to test for homogeneity, all you can simply do is just to substitute in lambda. Okay, when you substitute in lambda into f of x or into g of x, what we're getting is 2 lambda x plus lambda y, and if you factor out, you get lambda into 2x plus y. So this is lambda into f of x comma y. So lambda has a power of 1 here. Okay, so this is a homogeneous equation of degree 1. So this is a homogeneous differential equation of degree 1. Is that okay? So you can see now that each of the terms in this homogeneous differential equation have a power of 1. Okay, each term have a power of 1, and each of them are unique. We will see some other cases where each terms are mixed. So the next thing is, how do we solve this homogeneous differential equation? Now you already know that dy dx is 2x plus y over 2y minus x. So I usually like starting with this one as equation 0. Alright, so let's see where we're going. Now since this is equation 0, remember the first step. The first step is to substitute y equal to vx into this homogeneous differential equation. And how do you do that? You can do that simply by, first of all, you need to differentiate. Y equal to vx will be equation 1. Then when you differentiate vx, you're going to get v plus x dv dx. Okay, so if you're still having issues with some of these things, just see the last video I posted. I think I make a strong enough background for introducing us into homogeneous differential equations, so please watch the last video before this one. Now what we're going to do is, after you have differentiated y equal to vx, so you're now going to look for a way to substitute it into the original equation. So anywhere we see dy dx, it's going to be replaced with v plus x dv dx, and anywhere we see y in this particular right hand side, we're going to replace it with what? Vx. Now we'll do that and see what happens. So from equation 0, so this is how I normally say it. So put equation 1 and put equation 2 in equation 0 like this. So you are going to have v plus x dv dx in place of dy dx is equal to 2x plus y becomes vx over 2y, okay, another vx minus x. So you can see that x cancels out in all these scenarios. So this gives me 2 plus v over 2v minus 1, okay, because x is cancelling out. So we have v plus x dv dx is equal to 2 plus v over 2v minus 1. So x dv dx is equal to 2 plus v over 2v minus 1 minus v. Alright, so we're going to keep solving. Just follow me. So x dv dx is equal to 2 plus v minus, we have v into 2v minus 1 over 2v minus 1. So when you take the LCM, this is how you're going to get it. So if we expand the bracket, we're going to get 2 plus v minus 2v squared plus v all over 2v minus 1. So x dv dx is equal to, we'll have 2 plus 2v minus 2v squared all over 2v minus 1. Is that okay? 2 plus 2v minus 2v squared all over 2v minus 1. So at this point you can see now that we can separate variables. So we can separate variables from here. So we can separate the variables from here. So in separating the variables, this is what we're now going to get. We're now going to get 2v minus 1 all over 2 plus 2v minus 2v squared is equal to 1 over x. Okay, there's a dv here, sorry about that. Is equal to 1 over x dx, like this. So we have separated the variables. Okay, remember what we treated in the previous videos. Whenever you're separating the variables, a value that is on the numerator before will become in the denominator when it crosses over the equality, and a value that is in the denominator when it crosses over the equality, it goes to become in the numerator position. So you just kind of swapped the values like that. So you take all about x to the right hand side and you take all about v, you leave all the values pertaining to v on the left hand side. So we can now integrate at this point. So integrate, so we have the integral of 2v minus 1 all over I'm just going to rearrange this as minus 2v squared, okay, plus 2v plus 2, and this is with respect to v, and it's 1 integral of 1 over x dx. So let's see what we're dealing with here on the right hand side and on the left hand side. Now we are still going to use those integration techniques that we've built all this while up to this point. Now assuming you consider the denominator of the left hand side, consider this term for instance, and you want to differentiate it with respect to v. you want to differentiate minus 2v squared plus 2v plus 2 with respect to v. What you're going to get is minus 4v plus what? Minus 4v plus what? 2. Very good. So minus 4v plus 2. Now you can see now that this numerator over here is almost looking like this particular one over here. Okay, so if there is a way I can actually make this numerator over here look like this one over here, so first of all let me just wrap this one up. So d of minus 2v squared plus 2v plus 2 is actually going to give me minus 4v plus 2 dv. Okay, so here is what we are going to do now. So to make this particular numerator over here be like minus 4v plus 2, do you know that all we just needed to do was to multiply this particular numerator by minus 2? So in multiplying by minus 2, I have to what? Create a contingency or a reciprocal. Okay, so that this minus 2 will cancel the effect of this minus 2 under here, because minus 2 was not there initially. So if I'm creating a multiplier for minus 2, I also need to create something that can cancel this minus 2 that I introduced. So the essence of creating minus 2 is just to make this numerator conform to this form. So you have 2v minus 1 and dv all over negative 2v squared plus 2v plus 2. And this is going to be natural logarithm of x plus c in this case. So this is what we are going to have. So we are going to have 1 over minus 1 over 2, and we will now have integral of, so this particular place now is actually going to be what? Of course, minus 4v plus 2, okay, dv all over negative 2v squared plus 2v plus 2, and this is equal to min x plus c. So basically what we've done now, as you can see, is to convert the numerator from the original form it was to something like this. So I can replace this expression now, the whole of this expression, you can now replace it with what? D of this guy. Okay, so minus 1 over 2 integral of 1 over negative 2v squared plus 2v plus 2 d of negative 2v squared plus 2v plus 2 is equal to ln x plus c. Then at this point now, you will now notice that we have gotten back to our rule, and whenever you're integrating 1 over something d something, you're going to get ln something, okay, plus c, and so on and so forth. But since we've already put the integration constant here, I'm not going to put an integration constant on this side. So this gives me minus 1 over 2 natural logarithm of something, which in this case is minus 2v squared plus 2v plus 2, like this, and you now have it to be equal to ln x plus c. Are we together? So assuming we multiply through by minus 2, if we multiply through by minus 2, we're going to get this. We'll get ln minus 2v squared plus 2v plus 2, okay, is equal to negative ln negative 2 ln x and negative 2c. So you can call negative 2c to be something like d, for instance. So ln minus 2v squared plus 2v plus 2 is equal to, what you have here is negative 2 ln x then plus let's just call this one plus d for instance. Okay, so we're still going to do some manipulations now. So I would like to take all the variables to the left hand side and leave the constants on the right hand side. So I'll have ln negative 2v squared plus 2v plus 2, right? Then plus 2 ln x is equal to d. Okay, so at this point I have ln minus 2v squared plus 2v plus 2 plus ln x squared, law of logarithm, is equal to d. I'll now apply the product law of logarithm. Ln becomes minus 2v squared plus 2v plus 2 multiplied by x squared, and is equal to d. So that when we take the exponential of both sides, so you now have exponential ln the whole of this minus 2v squared plus 2v plus 2 multiplied by x squared is equal to exponential d. So remember that exponential ln f is equal to f. Alright, so you can now say that this whole left hand side simplifies to negative 2v squared plus 2v plus 2 multiplied by x squared, and we can call exponential d a since they are all arbitrary constants. Exponential d be a. Okay, so at this point you will now replace v with y over x. Is that okay? So anywhere we see v, we are going to replace it with y over x. So this is how it becomes minus 2 y over x squared, okay, plus 2y over x plus 2 in x squared is equal to a. So in the course of doing it like this, we can now multiply through by what? X squared. So use x squared to open these brackets, and what we'll have is what? Minus 2y squared. Okay, let me just do something first before I don't want to jump any step. Plus 2y over x plus 2, then x squared is equal to a. So when we open the brackets, we'll have negative 2y squared, okay, plus 2xy and plus 2x squared is equal to a. Okay, so we can actually divide through by 2, or let's say we divide through by minus 2. So you will now have y squared minus xy minus x squared is equal to negative a over 2. So let minus a over 2 be equal to something like k. So at the end of the day, you have y squared minus xy minus x squared is equal to what you have, k. So this is the solution, not just the solution, general solution for the homogeneous differential equation. Okay, so but we're given initial conditions, okay, but we were given and y of 2 is equal to 3. So y of 2 equal to 3 means that y is equal to 3 when x is equal to 2. So all you just need to do is to substitute it into these points. Wherever you see y, you put 3. So that will be 3 squared minus anywhere you see x, you put 2. Then you now have 2 squared is equal to k. At the end of the day, I'm having what? 9 minus 6 minus 4 equal to k. So what we have here is minus 1 is equal to k. So at the end of the day, we'll be having y squared minus xy minus x is equal to minus 1. Is that okay? Sorry, minus x squared equal to minus 1. So this can be how you can leave it, okay? Or someone can say y squared minus xy minus x squared plus 1 equal to 0. So this is the answer, and this is a particular solution. So you can see now that the initial condition given helps us to grow from our general solution. Our general solution is also called primitive to our particular solution. Is that okay? So our particular solution. So this is the answer for this particular case. So we are going to move on to the next example. We have about 4 more to solve. So tighten your belts. This is problem number 2, and we are given x cubed plus 3x y squared all into the y dx, and it's equal to y cubed plus 3x squared y. Okay, so x cubed plus 3xy squared dy by dx is equal to, we have y cubed plus 3x squared y. Now let's make the y dx subject of the formula. That's one of the first steps in homogeneous differential equation. You need to make the y dx subject of the formula. 3x squared y all over x cubed plus 3xy squared. Now from this example henceforth, I'm going to be using shortcuts. Okay, I'm going to be showing you short ways of determining some things. Now of course you already agree with me that from what we've developed so far, this right hand side is homogeneous. Of course, each term in the right hand side, okay, the total powers is 3. Okay, so you have x2 y1, and that's 3. You have x here 3, then x1 y2, that's 3. So it's homogeneous, okay, in degree 3. Okay, so it's homogeneous. So we can actually label this as equation 0. Then we can now say y is equal to what? Vx. Let's. So this is equation 1. Normal stuff. Then the implication is that dy dx will be equal to what? V plus x dv dx. And this is equation 2. Is that okay? Now you're going to put 2 and 1 in 0. Now here's what we're going to do. So watch me carefully. So I'm going to show you a trick now when you're substituting 2 and 1 in 0. So this is equation 0 over here, okay, for the record. So anywhere we see dy dx, so I'm going to replace dy dx with v plus x dv dx. Okay, so let's progress. Anywhere we see y, we are simply just going to replace it with what? V cube. Anywhere you see y, just put v there, so v will assume the power of whatever y is there. Okay, now anywhere you see x, just call it 1. Anywhere you see x, replace it with 1. So 3, 1 squared, and anywhere you see y, replace it with v. Is that okay? Anywhere you see x, replace it with 1. And anywhere you see x again, replace it with 1. And anywhere you see y, just replace it with v, and v will assume the power of y there. So this is the proof. Let me just prove it for you here. Even you have you want to do it the normal way, y equal to vx. So you have vx all cube plus 3x squared, then you now have vx all over x cube plus 3x, then you now have v squared. So you now discover that the numerator will now be v cube x cube plus 3x cube v all over x cube plus what? 3 okay, what happened? Oh, sorry, I missed something in this side. It was supposed to be v square x squared. Okay, v squared x squared. That's when you put y equal to vx here, to be v squared x squared. So you have x cube, then you have v squared here. Okay, x times x squared is x cube. Now you discover that all the x can be factored out. Let's factor out x cube, and you get v cube plus 3v all over x cube into 1 plus 3v squared. That okay, x cube cancels out x cube, and you can see now that this is just equal to this. So to save yourself the stress of like doing all these calculations from here downwards, save yourself that stress, just follow the trick. So you're going to put v for y and put 1 for x. So this is the cheat code you're going to use while you are transforming, or when you're putting equation 2 and equation 1 in equation 0. Okay, so that's what we're going to be doing, and I hope you understood that. Now let's continue. So as usual, x dv dx is going to be equal to v cube plus 3v all over 1 plus 3v squared minus v. So x dv dx will be v cube plus 3v all over, you have v into 1 plus 3v squared here, and 1 plus 3v squared. So this is equal to v cube, let's be careful here, 3v, and you now have minus v minus 3v cube. Okay, all over, you have 1 plus 3v squared. So I hope we didn't make any mistake in the expansion over there. So we have x dv dx is equal to, so v cube minus 3v cube gives me negative 2v cube, then 3v minus v gives me plus 2v all over, I have 1 plus 3v squared. So I can also write this one as 2v minus 2v cube all over 1 plus 3v squared. Is that okay? So at the end of the day, x dv dx is equal to 2v minus 2v cube over 1 plus 3v squared. Okay, so we are not going to separate variables. Separating the variables, I have 1 plus 3v squared all over 2v minus 2v cube dv is equal to 1 over x dx. So we are going to integrating, I'm going to get integral of 1 plus 3v squared all over 2v minus 2v cube dv is equal to, what do you have? Of course, integral of 1 over x dx. Alright, so let's move on from here and see what we're going to have. Now, in this particular case of integration, it's not going to be like the one that we've been seeing before. So assuming, for instance, you wanted to, with respect to v, you want to differentiate 2v minus 2v cubed. With respect to v, you're going to get 2 minus 6v squared. Okay, 2 minus 6v squared. So d of 2v minus 2v cubed gives me 2 minus 6v squared dv. Is that okay? So they are just trying to look at these two, for instance, and the numerator over here. There is no way on earth that you can make 1 plus 3v squared equal to 2 minus 6v squared. There is nothing you multiply 1 plus 3v squared to make it 2 minus 6v squared. Even if you want to use 2 into 1 plus 3v squared, you're going to get 2 plus 6v squared, and this is not equal to 2 minus 6v squared. So this method of integration that we know before is not going to work here, sadly. So we have to resort to another method. Now let's go flow with me together. So this is 1 plus 3v squared, and you have 2v is common into 1 minus what? 1 minus what? v squared. Is that okay? So this is dv, and this is equal to integral of 1 by x dx. So I hope you understood what we did. We just factored out, and since we factored out, it's now looking like we're going to apply the methods of partial fraction. But before we apply partial fractions, I'm going to factor out 1 over 2. Now consider the partial fraction 1 plus 3v squared all over v into 1 minus v squared. Okay, and this is still the same thing as 1 plus 3v squared over what? V into what? 1 minus v, 1 plus v. I hope you still remember difference of two squares, and this is a over v plus b over 1 minus v plus c over 1 plus v. So we're going to use cover up method, cover up method, cover up method. So cover up method is a good method of partial fractions when the denominator of your fraction is actually linear factors. So when you have all linear factors, please just use cover up method. And if you've not learned about cover up method, I could prepare a video about that much later, but you can check other YouTube sources and you will learn about cover up method. It's very, very efficient and indispensable as far as integration is concerned. So a, for instance, will be the limiting value. And interesting about cover up method is that you just need to look at the linear factor under it, and you ask yourself, what will I put into that linear factor to make it 0? Now the linear factor under a is v. Clearly my limits, v has to tend to whatever will make this linear factor 0, which is simply 0. So here is where the cover up comes to play a part. Now when I'm writing the original fraction, I'm not going to include whatever is under e, so I'll just include the other ones. So if I solve this limit, I'll have 1 plus 3 times 0 over 1 minus 0, 1 plus 0, and this is just 1 plus 0 over 1 times 1, which is 1. Okay, so a is done and dusted. So b is the limiting value as v tends to. So you now ask yourself, what should I substitute into this linear factor here? That's this one over here. What should I substitute to make it 0? And clearly you agree with me that that's 1. Okay, so when I'm writing the original fraction, I'm going to skip the linear factor under b, so it will just be the one for a and the one for c. So I'll have 1 plus 3 into 1 squared all over 1 into 1 plus 1. So this is 1 plus 3 all over 1 times 2, which is 4 over 2, which is 2. Okay, I hope that was straightforward. Then for c, is going to be the limiting value as v tends to what? Thank you very much. Minus 1. So 1 plus 3v squared over, you have v, then 1 minus v. Nice. So this is 1 plus 3 into minus 1 squared over, what do you have? Minus 1 into what? 1 minus 1. Okay, so this gives me 1 plus 3 over minus 1 into 2, and this gives me negative 4 over 2, which is actually negative 2. Okay, now we've gotten a, b, and c. Therefore, the partial fraction of this particular expression, 1 minus v, 1 plus v, evaluates to a plus 1. So we have 1 over v, and we now have plus 2 over 1 minus v, and minus 2 over 1 plus v. Okay, so this is how we organize the partial fraction, I believe. So b is 2 and c is minus 2. So back to our integration. So remember, this is our integration. This is our integration, and we're going to keep on integrating. So we have 1 over 2. Sorry about that. 1 over 2 integral of, so in place of the partial fraction I have 1 over v and minus 2 over 1 minus v. Sorry, there's a plus, and minus 2 over 1 plus v dv is equal to natural logarithm of x plus c. Okay, so assuming we keep going, we're going to get half, and you now have, this will be ln v, if you follow me, or let me just take it step by step so that you understand. But in the future I might have to jump some of these steps. So you have 1 over 2, I'll distribute the integral, or why don't I just multiply this integral, or why don't I just multiply both sides by 2? I'll multiply both sides by 2 from here. Multiply through by 2. That's both the left hand side and the right hand side. So when you multiply the left hand side and the right hand side by 2, you have integral from, I'm going to distribute the integral as well, 1 over v dv plus integral of 2 over 1 minus v dv minus integral and 2 over 1 plus v dv is equal to 2 ln x plus 2c. Okay, so that is what it's going to look like. So we are multiplying through by 2, and we are distributing the integral. On left hand side like this. So you're now going to integrate now. Take note, when you integrate you get ln v here. Okay, so no need of integration constant on the left hand side. Plus, now when you evaluate this particular one, you see now that there are some things we need to actually put in place. Now this is what I'm going to do for this one. This one is quite technical, but just flow with me. Okay, let's flow together. I just want to establish something here so that you understand. I don't want to jump the steps just because I want to assume you may know it, but just flow with me. Okay, now check this out. On the denominator I have 1 minus v, so assuming I'm differentiating with respect to v, 1 minus v, I'll get minus 1. So d of 1 minus v is negative 1 dv. Is that okay? And the same thing happens to the d of 1 plus v on the other side with respect to what? V, it gives me 1. So d of 1 plus v is actually going to give me what? 1 dv. Now I'm going to modify these integrals according to what we've just developed over here. Now this is what is going to happen: plus 2 into, okay, 2 over minus 1, for instance, into minus 1 dv and 1 minus v. Then you now have minus 2 over 1 into 1 dv and 1 plus v, so is equal to 2 ln x plus 2c can become d, for instance, so we let 2c be d. Okay, so this is how we modified the integrals. So remember, when you're integrating something like this, you now have to look for a way to modify the modify what you have in the integrand, so that it can now give you the d of what is in the denominator. So this is what happens. You now have 2 over minus 1. Integral of minus 1 dv is actually what? Minus 1 dv is d of 1 minus v. Is that okay? And minus 2 over 1 integral of, so 1 dv itself is still d of 1 plus v, and this is equal to what? 2 ln x plus d, like this. Is that okay? So if you do it this way, you get ln v minus 2. Then remember, integral of 1 over something, the something is what? Ln something, that's correct. So minus has come to this place, 1 minus 1, okay, or 2 divided by minus 1 is actually minus 2. So the integral of 1 over 1 minus v d1 minus v is going to be ln 1 minus v, and the integral of 2 over 1 into, minus 2 over 1 is minus 2. Then integral of 1 over 1 plus v d1 plus v is actually what? That's correct, ln 1 plus v. Then we now have 2 ln x plus d. Is that okay? So at the end of the day, this is what we have. Follow me together. I have ln v, right, minus 2 ln 1 minus v, okay, minus 2 ln 1 plus v minus 2 ln x is equal to d. Alright, so let's simplify this and see what we are going to get. So you have ln v, okay, then minus 2 into ln 1 minus v plus ln 1 plus v. Then you now have, what do you have again? And plus ln x. Is that okay? And this is equal to d. So flow with me again. This is ln v minus 2. I'll apply the law of logarithm here. So it will now be ln 1 minus v, 1 plus v, then x. Is that okay? Like this, equal to d. Then it will be ln v minus ln 1 minus v squared, that's difference of 2 squares, and you now have x, then you now have what? Squared. That's these two has risen up to this point is equal to d. So I'll now apply the quotient law of logarithms. So it will now be ln v all over what? 1 minus v squared, then x, everything here is squared, and all of them is inside one big bracket, okay, and this gives me d. So the rule is that ln a minus ln b is actually ln a over b. So that's just what we just did here, v all over the whole of this guy, like that. So at this point, when you take the exponential of both sides, taking the exponential of both sides, you're going to get v all over 1 minus v squared, because exponentially in something is that same thing in x all squared. It's just going to be exponential d, and I can call exponential d k, for instance. So we will now have at the end of the day that v is equal to k open brackets 1 minus v squared, then x, everything here all squared, like this. So this is not the end. You still have to what? Very good. Put v equal to y over x. So let's begin. So if v is going to be y over x, so this is what we're going to have. We'll have y over x is equal to k into, so let's be careful here, 1 minus, here will be y squared over x squared, then we'll have x like this all squared. So y will be k into x squared minus y squared over x squared, like this. So you now have x, so there's y over x here, sorry. You now have x like this all squared. So this right hand side is k. Then I'm going to expand these brackets now in terms of powers. So expanding it, follow me carefully. First of all, I'll get x squared minus y squared all squared. Then the x squared in the denominator is also all squared. Then the x here is also raised to the power of 2. Is that okay? So we will have y over x is equal to k. We now have x squared minus y squared all squared. So we now have x squared over x raised to the power of 4. Is that okay? So under all natural circumstances, we now have y is now equal to k x squared minus y squared all squared, and we now have x cubed over x raised to the power of 4, and this is going to be equal to k x squared minus y squared all squared 1 over x, like this. So for y equal to k x squared minus y squared all squared dot 1 over x, you can as well see xy is equal to k x squared minus y squared all squared. And finally, to wrap things up, you can see xy minus k into x squared minus y squared all squared is actually equal to 0. So this is a good answer or a good point where you can stop for this particular one. So I know it was long, but I hope you understood all the steps. Alright, let's move on to another problem. Okay, here we are at problem 3, and we want to solve x cubed plus y cubed equal to 3xy squared dy by dx. Now this is how you're going to go about it. Solution. So for this one, let me use another interactive ink over here so that we can go about it together. So we have x cubed plus y cubed is equal to 3xy squared dy by dx. So make dy dx the subject of the formula as usual. So dy dx is going to be equal to x cubed plus y cubed all over 3xy squared. Now without much doubt, you can see that it's actually homogeneous, since the power contributions from each and every term is actually 3. So you have 3 here, you have 3 here, and you have 1 plus 2, which is 3. So it's homogeneous, right? So as usual, this is equation 0. So you now say let y be equal to vx. This is equation 1. Then you now differentiate. If you make y vx, the y dx in this case will be actually v plus x dv dx. So this is equation 2. Now you're now going to substitute as usual. Substitute what and what? Substitute 2 and 1 in 0. Is that okay? When you substitute 2 and 1 in 0, remember this is 0, right? The y dx will now change to what? V plus x dv dx, and that will be equal to, then this right hand side over here, what is it going to change to? What is it going to change to? This right hand side. As you can see, remember the rule: anywhere you see x, put 1. Anywhere you see y, put what? V. So in putting 1 here, you have 1 cube. Is that okay? 1 cube is still 1. So y cube becomes v cube. Then I now have 3. X is 1. 3 times 1, 3. Then y is v, and that's v squared. Is that okay? So this is the simple way to like transform it. So we now have x dv dx is equal to 1 plus v cube all over 3v squared minus v. So x dv dx is equal to 1 plus v cube all over 3v squared and minus v into 3v squared. So if we simplify, we'll have 1 plus v cube minus, you have 3v cube all over 3v squared. Is that okay? So let's keep going. So x dv dx is going to be 1 minus 2v cube. So when you do v cube and minus 3v cube, you get minus 2v cube and all over 3v squared. Is that okay? So let's separate the variables now. We can actually separate the variables. So separating the variables. So separating the variables, we'll now have 3v squared over 1 minus 2v cube dv is equal to 1 over x dx, like this. So you now integrate, right? So when you integrate both sides, you have 3v squared all over 1 minus what? 2v cube dv is equal to integral of 1 over x dx. Alright, so let's consider the left hand side, okay, and see what we'll get. So for the left hand side, the denominator is what? 1 minus 2v cube. So assuming we want to d with respect to v, want to differentiate the denominator with respect to v, what we are going to get is minus 6v squared. Is that okay? Minus 6v squared. In other words, d of 1 minus 2v cube is actually going to give me what? Minus 6v squared dv. So is there a way I can make the numerator of this fraction minus 6v squared dv? Yes, of course. So all I just need to do is to multiply it by minus 2. Okay, 3v squared. If I can multiply it by minus 2, I'll have to divide again by minus 2 because minus 2 was not there initially. So take notes. So whatever you're multiplying, make sure you provide a countermeasure to reverse the effect. Okay, so 1 minus 2v cube, then and the v is equal to, this is natural logarithm of x plus c. Is that okay? Then see what happens now. So we now have negative 1 over 2 into, this becomes negative 6 v squared dv over 1 minus 2v cubed equal to ln x plus c. Now the numerator in the left hand side will now become, remember that we established, right? Remember what we established? We established that d of 1 minus 2v cubed is actually what? Minus 6v squared dv. So I can replace minus 6v squared dv with what? D of 1 minus 2v cubed. So replacing that, I'll get minus 1 over 2 integral of, first of all, 1 over 1 minus 2v cubed, then minus 6 v squared dv becomes d of 1 minus 2v cubed, and this is equal to ln x plus c. So if you integrate, integral of 1 over something, the something is equal to ln something, okay, and as usual exponential ln f is equal to f. So these are some of the foundational logics that we'll be using to solve our problems. Then take note of all of them. So you have minus 1 over 2 ln 1 minus 2v cubed is equal to ln x plus c. So let's multiply 2 by what? 2. Multiply 2 by, or 2 minus 2 rather, by minus 2. So multiplying 2 by minus 2, you have ln 1 minus 2v cubed is equal to negative 2 ln x negative 2c. So you can let negative 2c be equal to d, for instance. So this will now imply ln 1 minus 2v cubed plus 2 ln x is equal to d, okay, another arbitrary constant. So applying some logarithmic laws, 1 minus 2v cubed plus ln x squared over here is equal to d. So applying the product law of logarithm, log a plus log b is still the same thing as log a times b. Alright, so in this case you have ln 1 minus 2v cubed multiplied by x squared, one of them sharing one big bracket, is equal to d. At this point you can take the exponential of both sides, okay? So exponential ln 1 minus 2v cubed x squared is equal to exponential d. So exponential ln anything is that same thing, 2v cubed x squared equal to a. So where a is equal to exponential what? D. So at this point I think we are good to go. So first of all, you now have to put v equal to what? Y over x. So this becomes 1 minus 2y cubed over x cubed. Then you now have what? X squared is equal to a. So what we'll be having is x cubed minus 2y cubed over x cubed of x squared is equal to a. So this implies that we'll be getting x cubed minus 2y cubed, okay, all over x, because x squared cancelling out the x cubed to leave you with x in the denominator, and this will be equal to a. So we'll have x cubed minus 2y cubed is equal to ax, like this. So you can actually hang your pen like this, or for some of us that might want to still take everything to the other side, so x cubed minus 2y cubed minus ax equal to 0, or better still, x cubed minus 2y cubed over x is equal to a. But I'll rather leave our answer in this way. So any of this one you arrive at is still valid. Okay, it's still valid. How I wish I could actually show you something from this particular differential equation, but I'll leave that to later on, when we are treating perhaps partial differential equation in another future video. So please let's move on to the next problem. Problem 4, we are to solve y minus 3x plus 4y plus 3x in bracket and dy dx equal to 0. So let's solution. So let's try to be very fast in this one, since we've gotten enough background. Now this is still the same thing as y minus 3x plus, what do you have, 4y plus 3x dy dx equal to 0. So we'll attempt to make dy dx a separate of the formula. So 4y plus 3x dy dx is actually 3x minus y. Okay, when you take this one to the other hand, so and doing it like that, you now have dy dx is equal to 3x minus y over 4y plus 3x. Okay, so this is our equation 0. Our equation 0. Now, this being our equation 0, of course, is homogeneous, and the degree of homogeneity is 1. So you can now say let y be equal to vx. So this is equation 1, and of course dy by dx is going to be v plus x dv dx, and this is equation 2. Are we together? So as usual, substitute 2 and 1, substitute 2 and 1 in 0. So when you're substituting 2 and 1 in 0, are we together? When you're substituting 2 and 1 in 0, remember the rule, dy dx becomes v plus x dv dx, right? And equal to, anywhere on this right hand side now, anywhere you see, we've substituted dy dx to be v plus x dv dx. Now we're on the right hand side. Anywhere you see x, just change it to 1. So 3 times 1 is 3. Anywhere you see y, change it to v. And anywhere you see y again, change it to v. And anywhere you see x, change it to what? 1. 3 times 1 is 3. Alright, together. So this is what it becomes. Hence, you have x dv dx is equal to 3 minus v over 4v plus 3 minus what? V itself. So x dv dx is now going to be 3 minus v, then minus, you have 4v plus 3 into v, then over 4v plus 3. Is that okay? So when we open the brackets, we should be getting 3 minus v carefully, and minus 4v squared, and minus 3v over 4v plus 3. So x dv dx is going to be, so let's go gently, so 3 first of all, minus v minus 3v is actually minus 4v, and minus 4v squared, all over we have together. So continuing in this vein, we can now separate the variables. So separating the variables, we'll have 4v plus 3 all over 3 minus 4v squared. Everything here takes on dv is equal to 1 over x dx. Then you now integrate. So when you integrate, you have the integral of 4v plus 3 all over 3 minus 4v minus 4v squared dv equal to the integral of 1 over x dx. Okay, our usual trick. So our usual trick is to consider the d of 3 minus 4v minus 4v squared, right, with respect to v. So when we differentiate it, we are going to get minus 4 minus 8v. Is that okay? So minus 4 minus 8v. And clearly d of 3 minus 4v minus 4v squared now becomes negative 4 minus 8v into what? dv. So is there any way that we can make here equal to here? There is no way we can do that. There is no way we can actually do that. So we have to look for another way to solve this problem, and hopefully there may just be another way to solve it. So how about we try factorization? So consider factorization of the denominator in the left hand side, of course, 3 minus 4v and minus 4v squared. So let's try to factorize. So to factorize this particular stuff, I'm looking for two numbers that when I multiply, it gives me what? That's minus 4 times 3, which is negative 12. So two numbers, and when you multiply it gives you negative 12, and when you add it gives you negative 4. And clearly those two numbers should be negative 6 and plus 2. So we're going to have 3 minus 4v minus 4v squared is actually equivalent to 3 minus 6v, okay, plus 2v and minus 4v squared. So if we go ahead to factorize it, we'll have 3 into 1 minus 2v plus 2v into what? 1 minus 2v. So that works. We have 3 plus 2v and 1 minus 2v, okay, to be our factors. So we have our integral 4v plus 3 all over 3 plus 2v and 1 minus 2v dv is equal to integral of 1 over x dx. Alright, so let's keep going. Now if we consider the left hand side, we also need to consider the fraction in the left hand side, because definitely this is going to be integration by what? Partial fractions. So this corresponds to a over 3 plus 2v, then plus b over 1 minus 2v. If that is what you have, of course, let's find a as the limiting value. Then, sorry, not x this time around. V should tend to what? So you're now going to ask yourself, what is going to make this particular term 0? That's 3 plus 2v 0. want to make it 0, of course, v should be negative 3 over 2, right? So as v tends to negative 3 over 2, so the main fraction, I have 4v plus 3, then I'm not going to include it, so you have 1 plus 2v. So with respect to a, you're cancelling out, you're cancelling, striking this one out with respect to a. Okay, so this is going to be you have 4 into negative 3 over 2 plus 3 over 2 minus, sorry, over, is it 2 minus? That's 1 minus 2 into negative 3 over 2. So this gives me negative 6 plus 3 over 1 plus 3. Is that okay? So this gives me what? Negative 6 plus 3 is negative 3 over 4. That's A. Negative 3 over 4. That's A. So let's go ahead to find B. Let's go ahead to find B. So B is going to be limiting value as V approaches what? Thank you very much. V is going to approach this time around 1 over 2. Because if we make V 1 over 2, then this linear factor is going to be 0. You can check it out, plug in 1 over 2 and see what you get. Of course, 2 times 1 over 2 is 1 and 1 minus 1 is 0. So in the main fraction 4v plus 3, I'm going to exclude 1 minus 2v while I leave 2v. So the exclusion of 1 minus 2v is what we call covering up. I'm covering up the linear factor in the main factors, in the main fraction, so that I can apply the limits, okay, to the other fractions, to the other expressions that will remain. So you have 4 into 1 over 2 plus 3 over 3 plus 2 into 1 over 2. So definitely this gives me 2 plus 3 all over what? 2 plus 3 all over 3 plus 1, and this is a 5. So I have a negative 3 over 4 and I have a 5. So anytime I see the fraction 4v plus 3 all over 3 plus 2v, then 1 minus 2v, I can still say that this fraction corresponds to negative 3 over 4 into 3 plus 2v, then plus 5 over 4 into 1 minus 2v. Okay, so let's see where this leads us to. So back to the integral. So our integral, of course, had the fraction, right? So I'm just going to integrate it and replace the fraction with, the partial fraction now. Now have 3 plus 2v and plus 5 all over 4 into 1 minus 2v dv is equal to integral of 1 over x dx. So let's begin. I'm going to distribute the integral on the left hand side. I'll get negative 3 over 4 integral of 1 over 3 plus 2v dv plus 5 over 4 integral of 1 over 1 minus 2v dv is equal to natural logarithm of x plus c. So what we are now going to get for this particular side is this. So let's fill together. Of course, remember, we're going to do our transformations as usual. So our transformations, we have d of dv, that's 3 plus 2v. d with respect to dv, 3 plus 2v gives me 2. So d of 3 plus 2v is actually 2 dv. And in the same vein, d of 1 minus 2v is going to give me negative 2 dv. Negative 2 dv. So So what should I do on these particular places to convert it to these particular forms that we've established? So for this particular one, first of all, you need to introduce a 2 here, 2dv, right? And remember to counter it by introducing a 1/2, okay? Then plus 5/4. You need to introduce what? A minus 2dv here, 1 minus 2v, and you have to counter it by introducing a minus 2, okay? Then equal to ln x plus, then I can say let C be ln A, and I'll explain why later. So ln A, for instance, so you have negative 3/8 integral of, now this 2dv can now become what? D of what? Thank you very much. 3 plus 2v. Then this is now a minus 5/8 integral of 1/1 minus 2v. Then this is d of 1 minus what? 2v. That minus 2dv is now d of 1 minus 2v. Okay, so this is equal to what? Ln x plus ln A. So let me leave the right hand side like that. I'm not going to apply the law of logarithm yet. So if we solve this one, we'll get minus 3/8 integral of this one, integral of 1/3 plus 2v with respect to 3 plus 2v is actually going to be ln 3 plus 2v. Okay, then minus 5/8 now ln 1 minus 2v is equal to ln x plus ln A, for instance. So we are going to be having in the long run, let's put it together. We're going to be having, sorry, we multiply through by 8. Minus 8 rather. If we multiply through by minus 8, I'll have 3 ln what do you have? 3 plus 2v, like this. Then minus 8, that's plus 5 ln 1 minus 2v. We are multiplying through by minus 8. Okay, take note of that. So this will be negative 8 ln x, negative what? 8 ln A. So I'll show you just how well we can manipulate our arbitrary constants. We can manipulate them anyhow we want. Okay, it doesn't really matter much. So this is gonna be ln 3 plus 2v all cube plus ln 1 minus 2v raised to the power of 5, then plus 8 ln x is equal to, let me just call this one ln A raised to the power of negative 8. So I can say let A raised to the power of minus 8 be k, for instance. Okay, so you have ln 3 plus 2v all cube plus ln 1 minus 2v to the 5 plus ln x to the 8 is equal to ln k. So we're going to apply the law of logarithms on the left hand side. Okay, that's ln 3 plus 2v all cube, then 1 minus 2v to the 5 to ln k. So by the time we take the exponential of both sides, so of both sides, when we take the exponential of both sides, we'll have exponential ln 3 plus 2v all cube, and 1 minus 2v 5, and x to the 8th is equal to exponential ln k, and exponential ln f is f, okay, because exponential is the inverse function of logarithm, and logarithm is also the inverse function of exponential. Later you also discover that ln exponential f is also f. Lucky. So let's keep on going. This left hand side reduces to 3 plus 2v all cube, and 1 minus 2v to the 5, then x to the 8 is equal to k. So put v equal to y over x. Alright, put v equal to y over x. We are rounding up this problem. So you have 3 plus 2y over x all cube. You now have 1 minus 2y over x raised to the power of 5. And you now have x raised to the power of 8 equal to a constant. Check what happens out. You have 3x plus 2y over x raised to the power of 3, and you have x minus 2y over x raised to the power of 5, then x raised to the power of 8 equal to k. So 3x plus 2y cube over x cube, and x minus 2y to the power of 5 over x to the power of 5, then x raised to the power of 8 equal to k. So if you are familiar with the law of indices, then the denominator of the left hand side will be x raised to the power of 8, then x raised to the power of 8 equal to k. So x raised to the power of 8 strikes out x raised to the power of 8, and we now have finally that's 3x plus 2y raised to the power of 3, and x minus 2y raised to the power of 5 is equal to some arbitrary constant. So this is where you can rule the line for this particular problem. So I hope you are still following up to this point. Grab your pen and don't give up. We have one more problem to go. So let's move on to the last problem. Alright guys, welcome to problem 5. We want to find the general solution of the equation y prime is equal to 2xy plus y squared over x squared plus 2xy. So let's go ahead and attempt that. So y prime can be written as dy dx. Dy dx is equal to 2xy plus y squared over x squared plus 2xy. Okay, so this is already arranged for us. There's no need to make dy dx the subject of the formula because the question came prepared for us. Now, of course, the test for homogeneity will confirm that this is a homogeneous differential equation in degree 2, since each term for this particular expression on the right hand side have a total power of 2. X is 1 here and y is 1, and 1 plus 1 is 2, so y is already 2 here, x is already 2 here, and x 1, y 1, 2, y 1 plus 1 is 2. So as usual, we're going to let y to be vx. So remember the labelings of our equations. This is equation 0, this is equation 1. Therefore, if we let y be vx, dy dx is now going to be v plus x dv dx. This is going to be equation 2. All together. So now, next thing to do is to substitute. Substitute 2 and 1 in 0. Of course, remember the rules. Put dy dx to be v plus x dv dx. So every y changes to v, every x changes to 1. So this is my shortcut, the one I normally use. I'm giving it to you to make things simpler for yourself. Okay, so assuming you now want to transform the equation from the dy dx domain to the dv dx domain. So dy dx becomes v plus x dv dx, and I'm referring to this dy dx over here on the left hand side. So let's go together. So you have 2x. Any x becomes 1. 2 times 1 is 2. Any y becomes v. So you have 2v plus any y becomes v. So y squared becomes v squared over. So any x becomes 1. So 1 squared is 1. And finally, any 2xy will be simply 2v, like this. So you can now go ahead in what solving this problem, and let's see how we are going to go about it. As usual, x dv dx is equal to 2v plus v squared over 1 plus 2v minus v, like this. Then this will give me x dv dx is 2v plus v squared minus v into 1 plus 2v, okay, over 1 plus 2v. So open bracket very carefully, 2v plus v squared minus v minus 2v squared over 1 plus 2v. So that's right, let's keep going like this. So you have x dv dx is going to be, so we have 2v minus v is going to give me 1v. Then we have v squared minus 2v squared, v squared minus 2v squared, and that should give me a minus what? V squared itself. Then over 1 plus 2v. So at this point, separate variables, separate. Separate the variables at this point. Here's what we're going to get. Of course, you should have 1 plus 2v over v minus v squared dv is equal to 1 over x dx. So integrate. When you integrate, what are you going to get? Integral of 1 plus 2v over v minus v squared dv is equal to 1 over x with an integral with respect to x. So let's test our left hand side as usual to see if it satisfies some certain criteria. Now, when you d with respect to v, that's v minus v squared. Sorry about that. V minus v squared, you're going to get 1 minus 2v. So in other words, d of v minus v squared is 1 minus 2v dv. What we have on the numerator over here is 1 plus 2v. So this method unfortunately will not work. So we can actually factorize and result to another method. So let's go ahead and factorize. Okay, now this is how we're going to factorize. We have 1 plus 2v into, you can take out v from here and becomes 1 minus v like this. So the v is equal to integral of 1 over x dx. Then what we are going to have left is to try to split the fraction here into its partial fraction. So this one is pretty straightforward. Consider you have to split it. This is a over v plus some b over 1 minus v. Now you are going to find out that a is limiting value as v tends to what? Correct? 0. V tends to 0. Okay, because 0 is what you're going to put over here to make it 0. So in the main expression for the fraction, you're going to cover up the linear factor under a, and you're going to be left with 1 minus v. So when you solve this limit, you have 1 plus 2 times 0 over 1 minus 0. This gives me 1 over 1, and this is 1. Going down to b will be the limiting value as v tends to what? That is very correct, 1. So you have the main fraction 1 plus 2v. So you're going to cover up the linear factor for v on this side. So in covering up, you're going to be left with only v. So you are going to have 1 plus 2 into 1. That's by applying the limits, direct substitution. So this gives you 1 plus 2 all over 1, and this is equal to 3. Okay, so I believe that we can keep on going from here. So our integral becomes integral of a being 1 over 3, 1 over v, sorry, and b being what? 3 over 1 minus v dv, and everything is equal to integral of 1 over x dx. So let's keep solving. So what are we going to have in this case? I'm going to distribute the integrals. So in distributing the integral, I have integral of 1 over v dv plus integral of 3 over 1 minus v dv. And this one just evaluates to the x plus constant of integration. So the left hand side, I'll have, let me just call this one ln v, n plus 3 integral of 1 over 1 minus v dv is equal to ln x plus c. So at this point, I want to argue that you're not conversant with the method of integration that I'm going to apply here. This is how I'm going to apply it without even having to write. So this is 3 over minus 1, and integral of minus 1 over 1 minus v dv, and equal to ln x plus c. So you can now see that this is all getting us back to the rule that we have been applying on this particular side. So that rule, I just want to blend it with quotient rule now. It said that if you're integrating a quotient and you discover that the denominator is actually the differential coefficient of the numerator rather, sorry, the numerator is the differential coefficient of the denominator. That means that if you're integrating something over something and you discover that that when you differentiate the factor down, you're going to get whatever is up there. Differentiating this factor down here gives you this one. Then your answer is going to be ln of the denominator plus c. Okay, that's your quotient rule of differentiation. And clearly, if we differentiate 1 minus v with respect to v, we're going to get minus 1. Okay, so it's just as good as what we've been doing before, but I'm not going to take too much long steps. Let me just write in negative 3 here. So this is just going to be ln 1 minus v. Okay, so I'll leave you to do that magic step by yourself. So I just want to quickly finish up this one. And x plus c. Then you have ln v minus ln 1 minus v raised to the power of 3 is equal to ln x plus c. So check out what happens. I'm going to say let's c be ln a. Then see what happens. Ln v minus ln 1 minus v raised to the power of 3 is equal to ln x plus ln a. Okay, where ln a is another arbitrary constant on its own. So you can make crazy assumptions with arbitrary constants just to suit your purpose. You're actually allowed to make your arbitrary constant literally anything you want it to be, but you have to choose wisely so that it will blend with your equation. Like see now, making it ln a, it makes it easy for me to apply some laws of logarithm in this place. See what I'm going to have. I'm going to have ln, on the left hand side we'll have the quotient law, okay, of logarithm laying out, while on the right hand side we'll have the product law of logarithm playing out. So when we take the exponential of both sides, we're going to have e to the ln v over 1 minus v cube is equal to e to the ln ax, and according to our axiom, exponential ln f will still return f. So we have v over 1 minus v cube is equal to ax right together. So let's see how this eventually simplifies. We're going to get v is equal to ax into 1 minus v raised to the power of 3. So put v equal to y over x. So y over x is equal to a into 1 minus, there's an x here, sorry about that, 1 minus y over x whole cube. So just to simplify, you have y is equal to ax squared into x minus y over x whole cube, and this is ax squared into x minus y cube over x cube. over x cube. Then this is actually a into x minus y cube over x. So finally we have y to be a into x minus y cube over x. In other words, xy is equal to a into x minus y cube. So someone can say, this is where I drop my pen, or someone can still say xy minus a x minus y all cube equal to 0. So any of this one can do, and this is the solution, or the general solution that we have been looking for all this while. Wow, we have come to the end of this series on homogeneous differential equations. So I believe we've solved a lot of homogeneous differential equations, 5 problems at least to get you started. There are still more problems on homogeneous differential equations, but these ones are starter problems to test your hands and to make you ready for more bigger problems. But try your best to get used to it, solve more examples, and try more things by yourself. And all the integration techniques I've shown you in this video, try to wrap your head around them and try to understand them. And as usual, if there is still any confusion, there's still any question, there's still any case you need to call my attention, please do so, and I would attend to you. Like this video, subscribe, share, help grow my channel, and hit the notification bell to stay updated. So in the next series we're going to be considering Bernoulli's equation, and we're going to consider exact equations, and after which we'll move on to second order differential equations and touch some few concepts there, hopefully. Okay, stay tuned, and thank you very much. Bye till the next video.